Hi, so the problem I will be doing today is problem number 8, and problem number 8 states, a simple model of a core tornado is a right circular cylinder that rotates about its axis. If a tornado has a core diameter of 240 feet and a maximum wind speed of 240 miles per hour or 352 feet per second, at the perimeter of the core, approximate the number of revolutions the core makes each minute. And it wants you to round your answer to the first decimal place. So what I've already done is broken this problem into 3 steps, and I pulled out the important information that we're gonna need. So the 2 important things that you're gonna need from this problem is your max wind speed, and mine is 352, and then your core diameter, mine is 240. So the first thing that I said that we should do is find the perimeter. And to find the perimeter, if you don't remember, I've already wrote the formula right here at the top, and it's just 2 pi r. So basically, if we were to write that out and go ahead and do that for this problem, we'd have 2 times pi, and for r, your radius is half of your diameter. So you would divide your core diameter, which is, for me, is 240. So I know half of 240 is 120. So I'm gonna write that in a different color. I think I'm gonna do green. Okay. So I'm gonna do 120, and you just plug that in your calculator. Let's see. And if I plug that in, do 2 times. It gives me a really big number, but I'm just gonna, since we're only doing, let me see, the answer is only gonna be to the first decimal place, so I would take, for mine, I took the first 2 decimals. So it's gonna be 0.98. And for the next one, for the second step, we're gonna multiply the spins per second by 60. And the reason we're doing this is because we're trying to find the times per minute, and by giving the seconds, we just need to basically turn that into minutes. So there's 60 seconds in a minute, which is why we're going by 60. So for this one, again, we're gonna plug in the max wind speed, and mine is 352, and I'm gonna write that in a different color so you can see that. And then we're gonna do that times 60. And when I plug that in, I believe the number that I got, let's see, is 211.20. So the next thing after you have your 2 values is what you want. We have our perimeter, and we also have the number of times per minute. We have the spins per minute, but the problem tells us we're trying to find the number of revolutions for each minute. So that's what we're gonna do down here. And for this, we're just gonna take these 2 values that we found previously. Right here, we're gonna take that 753, and then we're gonna take this and we're gonna divide. But when you divide, you're gonna divide the number of spins that we found. So let's see, I did that in blue, so I'm gonna do it in blue here. I'm gonna take 211.20, and you're gonna divide that by the 753.98. And for my answer for that, of course, with rounding to the first decimal place, I got 28.0, and that is my final answer. So let me see, and it asks you basically, once again, to find the revolutions per minute, which we found by dividing the spins by the perimeter. So once again, everything that we have here that we plugged in is in green. So the first thing, like I said, you're gonna calculate your perimeter. Just use that 2 pi r, and then you just take that value from there, and then you use your other value, and you're gonna divide, and you will get the number of revolutions per second. per minute, I'm sorry.